Section 9.1, we're going to talk about vectors in 2 dimensions. This is just the first half of the lesson. A vector is a plane, is a line segment with an assigned direction. You probably talked about vectors in physics. Vector had a distinct endpoint and went off in some direction. It was just a ray. And it usually goes from one point to another point, and the reason for the arrow is it tells you what direction it's going in. Vectors have magnitude and direction. They have a length and they have a direction of travel. So if you think about in physics, when you talked about speed, you're traveling 60 miles an hour. That's just your magnitude. If you say you're traveling 60 miles an hour south, that has magnitude and direction, and it's a vector. 2 vectors are equal if they have the same length and the same direction. So if I say to you these 2 are about the same length, they're going the same direction, they must be equal vectors, even though they're not on top of one another. We can add vectors together. So if I say this is vector A and this is vector B, the way we add them together is one of 2 ways. You either take vector B and stick it here. The sum would be this. Or the other thing that I could have done was, instead of moving vector B, I could have moved vector A over here. And I want you to notice that the sum ends up being the same vector. It's called the resultant vector. When you have a vector of a certain length, if you multiply that vector by 2, it just doubles the length. If you multiply the vector by a negative, it just makes it go in the opposite direction. Vectors are usually denoted by a bold-faced letter, but I can't write a bold-faced letter, so we instead use a letter with a little arrow over the top. That's how we write it. Vectors follow all the properties of real numbers, so that is pretty self-evident. When you see the problem, you'll just be like, oh, okay, I know how to do this. Subtracting a vector is going to be a little bit different. If I want to, here's A and here's B, and say I want to do A minus B, we first do negative B, which means that you just make B have the same length but go in the opposite direction. And then your resultant would be here. Vectors are written like this. Those are not the less than and greater than symbol, by the way, but they kind of look like it. Vectors kind of look like ordered pairs, and they're written between these weird little, looks like inequality symbols. They represent components on the coordinate plane. So if you think about them like x and y components, this moves the vector horizontally, and this one moves it vertically from an initial point. So in order to find a vector, you have to have an initial or starting point, and you have to have an ending or terminal point. To find a vector, if you have an initial point, x1, y1, and a terminal point, x2, y2, you can find the length of the vector by simply doing terminal minus initial, terminal minus initial. So let's say I tell you I have a vector, u. It starts at -2, 5 and goes to 3, 7. And I want to look at this graphically for a moment. Here would be -2, 5. And then 3, 7 would be up here somewhere. Since this is the initial point and this is the terminal point, this is what the vector would look like. To find the component form of the vector, all you have to do is do the terminal x minus the initial x, the terminal y minus the initial y. So we're going to find out that vector u in component form is 5, 2. How about if I tell you a vector v has the component form 3, 7 and is sketched with initial point 2, 4? What is its terminal point? I always like to look at these graphically because I think it helps out a little bit. So here's my initial point, and all I know is that its component is 3, 7. That says that the terminal point is 3 units to the right and 1, 2, 3, 4, 5, 6, 7 units up and ends up here. So there's my vector. So where am I at? Well, if I go 3 units to the right, I'm at 5. So the terminal point must be at 5, comma, and then if I go 7 units up from where I started, I was at 4, I went up 7, so I must be at 11. So the terminal point must be at 5, 11. Now we're going to sketch representations of the vector w in component form 2, 3 with initial points 0, 0, 2, 2, negative 2, negative 1, and 1, 4. So let's just say I start at 0, 0. If the component form is 2, 3, that means you go 2 to the right and 3 up, and that's where you would end. So now I'm going to get rid of this because I don't need that. Make that look nicer. Alright, what if instead I start at 2, 2, which is here, and I go 2 to the right and 3 up? Well, that's where I'm at. Now I'm going to get rid of this. You'll notice that it has the same length. It's pointing the same direction, it's just not in the same place. Alright, how about negative 2, negative 1? And I go 2 to the right and 3 up. I'm going to end here. Get rid of this. Again, same length, same direction. And what if I start at 1, 4 and I go to the right 2 and up 3? All these vectors have the same length and the same direction. They had different initial points. They're all equal vectors. What if I actually wanted to know the length of a vector? The length or magnitude of a vector v in component form ab is just the square root of a squared plus b squared, which is a formula that I've been spending a lot of time working on because it's just the Pythagorean theorem. Who would have thunk it? The reason it's the Pythagorean theorem is because if you think about this, what's the component form tell you? It says start at some initial point, you go a units this way, and b units this way, and then here's your vector. So it's just the Pythagorean theorem. So let's find the magnitude of each vector in problem 2. So for the first one, it's going to be the square root of 2 squared plus negative 3 squared, which is going to be 4 plus 9, which is the square root of 13. I'm going to leave it as the square root of 13 because I have no interest in turning it into a decimal. The second one is going to be 5 squared plus 0 squared, which is the square root of 25, which is 5. And the third one, 3/5 squared plus 4/5 squared, which is 9 over 25, plus 16 over 25, which is 25 over 25, which is 1. I mentioned earlier that vector properties follow all the properties of real numbers. So if you want to add two vectors, just add their x components, add their y components. You want to subtract them, subtract the x components, subtract the y components. You want to multiply a vector by a number, distribute that number to everything inside the component form. So, very quickly, if vector u is 2, negative 3, and vector v is negative 1, 2, we want to find u plus v, u minus v, 2u, negative 3v, and 2u plus 3v. So I'm going to start with u plus v. All you have to do is add the x components, add the y components. That's it. You have to be careful when you're subtracting, though. Make sure you subtract. So 2 minus negative 1 is 3. Negative 3 minus 2 is negative 5. 2u. is going to be 4, negative 6. Negative 3v is going to be 3, negative 6. And then to do 2u plus 3v, we already know 2u is 4, negative 6. And then 3v, if I ignore the negative, 3v is going to be negative 3, 6. So when I add those together, I'm going to get 1, comma, 0. And that's what 2u plus 3v is. It's really just adding and subtracting integers. That's all it is. As I said earlier, all the properties of real numbers hold true for all the vectors. We also have these special type of vectors called the unit vector. Remember how the unit circle was a circle of radius 1? Well, the unit vector is a vector whose length is 1. And the two vectors that we focus mostly on are the vector that lies on the x-axis, that's of unit 1. We call that vector I, and its component is 1, 0. It means go 1 unit to the right, but don't go any up. And then j is the vector of length 1 that lies on the y-axis. And its component form is 0, 1, because 0 means don't go left or right, but go 1 up. We can rewrite the component form of vectors in terms of I and j. So instead of writing this, I can write it as this. Pretty simple. In example 4, I want to write vector u, 5, negative 8, in terms of I and j. Okay, all I have to do is this. 5i minus 8j, and that's it. B, if u is 3i plus 2j and v is negative I plus 6j, write 2u plus 5v in terms of I and j. Well, first let's find 2u. 2u is going to be 6i plus 4j. 5v is going to be negative 5i plus 30j. And then I'm just going to add those together. You add like terms. You get 1i plus 34j. And that's it. And that's the end of part 1.